My name is Wassay Gulrez. I will talk about pressure tension test and advancement in concrete practice. Concrete is a composite material. It is a mixture of cement, sand, water, and rock. Concrete is very cheap. It's only 5 cents a pound. We are producing approximately 6 billion cubic meters of concrete around the world per year. When a concrete structure is used, it experiences two major types of forces, a compression force and other is tensile force. To make these forces understand, I will take an example of a spring. When I pull apart its ends, it's in tension, but when I press it together, it is in compression. And same happens with the concrete. Concrete is so strong in compression that a small concrete cylinder can withstand a weight of 25 elephants stacked on each other, but it is so weak in tension that Mr. Universe can pull it apart. Now, over the years, the scientists and engineers has developed standard methods and machines to test the concrete in compression, and they are very successful in it. But unfortunately, they are not able to give us a proper or standard method or machine to test the concrete in tension. In 1970s, there was a British engineer, when he was brushing his teeth, he squeezes the toothpaste with his hand and saw that the paste pops out with a force. This gave him an idea that in a similar way, we can test the concrete in tension. This idea doesn't work out at that time. In 1990s, people again started working on that idea and they're still working on it. Now, at OSU, we got an opportunity to develop a pressure tension machine to test the concrete in tension. It consists of a metal chamber in which we will test 4 by 8 inches of concrete cylinder. It has an inlet at the center through which we will insert a pressurized gas into the chamber. Both ends of the chamber are sealed with the rubber rings to make it airtight. The pressurized gas goes into these inlets and applies a biaxial load along the longitudinal length of the cylinder and breaks it in tension. Now, how this failure mechanism works. If I take a cross-section of a concrete cylinder and see it under the microscope, it has many capillary pores and air voids in it. The pressurized gas goes into these pores and applies the pressure on the walls of these pores and breaks it at its weakest part. This is how we will determine the tensile strength of the concrete. And this work will help us to make a better concrete in future. Thank you for your time.